friends, welcome back to our channel Physics Tutorial. Today we are going to discuss the NCERT textbook solutions of 9th standard physics, that is gravitation. So we can move to the question. The first question is, how does the force of gravitation between two objects change when the distance between them is reduced to half? That is, here we have to find the force of gravitation between two bodies, that is m1 and m2 are the masses of the two bodies and r is the distance between the between the masses. So what will happen to the force of gravitation between the two masses when the distance is reduced to half, that is r becomes r by 2. So in such a case, what will happen to the force of gravitation that we have to find? Then we have already studied from universal law of gravitation, that is the force of attraction between the two bodies of masses m1 and m2 which are kept at a distance of r can be written as F is equal to g into m1 m2 by r square. This is very important equation. Here G is, yes, this is a constant and it is called a universal gravitational constant. And m1, m2 are the masses of the two bodies and r is the distance between m1 and m2. So this equation should be thorough. Okay, that is F is equal to g into m1, m2 by r square. That is the general equation for universal law of gravitation. And now we can apply the condition. What is the condition here? Here it is given that the distance between them is reduced to half. So what will happen? Distance becomes half means r becomes r by 2. Okay, so r will be equal to r by 2. So how we can write the equation? R dash, here the new distance we can take as r dash. Okay, so r dash will be equal to r by 2. So instead of r, here we can substitute r by 2. So what we will get? F is equal to g into m1 m2 by r by 2 the whole square. Right, so what is that? R by 2 the whole square means r square by 4. Then F is equal to g into m1 m2 by r square whole divided by 4. So when we rearrange it, how we will write? Yes, F is equal to 4 into g m1 m2 by r square. Okay, so this will move to numerator. So what we will get? 4 into g m1 m2 by r square. So that is the force of gravitation between the two bodies when the distance between them is reduced to half. So here what happens? Here g into m1 m2 by r square is the force itself, right? So initially the force was g into m1 m2 by r square. Now we are getting 4 into F. Okay, that is 4 into g m1 m2 by r square. So how we can say that? The force becomes 4 times that of the previous value. Okay, because the force of gravitation becomes 4 times that of the initial value when the distance between them is reduced to half. So like this we have to find the force of attraction between the two bodies. Okay, clear? Now we can move to the second question. The question is, gravitational force acts on all objects is in proportion to their masses. Why? Then a heavy object does not fall faster than a light object. That is the question. That is, gravitational force acts on all the objects. That means that is proportional to their masses. Okay, we have already told that in the case of universal law of gravitation, we studied the force of gravitation between the two bodies is directly proportional to their product of masses. That means it is proportional to their mass. But why a heavy object is not falling faster than a light object? Suppose if we are putting two objects, a coin and a paper from the same tower or from the top of a building, and both the things, that means the paper and the coin, both are having different masses, but they will reach the ground at the same time. So there we have to avoid the air resistance. Okay, so we have to neglect the air resistance. In such a case, we have seen that both the objects, irrespective of their masses, they will reach the ground at the same time, and Galileo has proved that also. Okay, from this, how we can give the explanation for that? Because that gravitation force actually depends on their masses, because that is directly proportional to the product of their masses. But why a heavy object is not falling faster than a light object? That is our question. So how we can answer that? Here we have seen that in the case of free fall, the all the objects will be falling with a constant acceleration. Okay, constant acceleration, and it is known as acceleration due to gravity. That is G, small letter G. That is the acceleration due to gravity. So Earth will be attracting all the objects towards the center of the Earth with a value 9.8 meter per second square, that we have told it. Small letter G is equal to 9.8 meter per second square, right? So this value is constant and which is independent of the mass of the object. That is, all the objects will be attracted towards the center of the Earth with a constant acceleration, so that whenever we put that coin and paper together, so what will happen, both will be attracted towards the center of the Earth, and that acceleration is known as acceleration due to gravity. Okay, so that value is 9.8 meter per second square. So no need to mention that value, you can just mention that this is called acceleration due to gravity, and that value is constant, so that we can see that the actual value of acceleration due to gravity is 9.8 meter per second square, and it is independent of mass of the object. Okay, so whenever we calculate the value of G, that we will discuss later. So small letter G, if we calculate the value, we can see that it is independent of mass of the object. That is why the heavier and lighter objects falls to ground with the same speed. So that is why we can say that a heavy object does not fall faster than a lighter object. So how we can answer? All objects fall towards the ground with a constant acceleration called acceleration due to gravity. Okay, and it is constant and is independent of mass of the object. That is why a heavy object does not fall faster than a lighter object. Clear? So like that we have to understand the concept, and then it is very easy to answer. Actually this chapter is very interesting chapter, but whenever we are getting such questions, you have to understand the idea how that works or why it happens. So it will be very interesting to answer. Hope it is clear to you. Now we have third question. The question is, what is the magnitude of gravitational force between the Earth and 1 kilogram object on its surface? So here we have to calculate the magnitude of gravitational force. That means the gravitational force we have to calculate between the Earth and 1 kilogram object on its surface. So consider here we have Earth and 1 kilogram mass, that is small letter m. Suppose the mass of Earth is capital M, and here we are taking the small letter m as the mass of an object which has 1 kilogram. Okay, so here on the surface we have kept this mass, and we have to calculate the force between, that is the gravitational force between these two, that is the Earth and 1 kilogram mass. So how we can calculate? Here we have two masses, that is first one is Earth and the next one is that 1 kilogram mass which is kept on the surface. So here we can see that on the surface of Earth we are keeping this 1 kilogram mass, means what will be the distance of separation between these two? Here from the center of Earth the attraction is there, means this is the radius, right? So this is the radius of Earth, so that will be the distance between these two objects. Clear? Because the Earth is attracting the mass towards the center. So here we have the distance, that is the radius given as 6.4 into 10 raised to 6. That is the radius of the Earth. And that distance will be here because on the surface the mass is kept. 1 kilogram mass is kept on the surface of the Earth. So the distance between these two masses can be taken as the radius of the Earth. And the capital M, that mass of the Earth is given as 6 into 10 raised to 24 kilogram. That is the mass of the Earth. And M, small letter m is 1 kilogram. Now we have to calculate the magnitude of gravitational force between Earth and 1 kilogram mass. So how we can find? There are two masses, m and small letter capital M and small m, and the distance is r. Then what will be the force between the two masses? One mass is Earth and the other mass is 1 kilogram mass. Okay, so how we can find the force? The same equation we can use. Okay, so which is the equation? F is equal to G m by r square. Okay, so here we have the values of this. Capital G is universal gravitational constant, capital M is mass of earth, small letter m is the mass of, that is 1 kilogram object. Okay, and r is the distance between earth and the mass, that is taken as the radius of the earth. That value is given here, 6.4 into 10 raised to 6 meter. And capital G is a constant, universal gravitational constant. That value you have to know, because whenever we want to calculate the force, we have to substitute that value. So make sure that the equation and the value of G is clear to you. Okay, so here G is equal to 6.7 into 10 raised to minus 11 Newton meter square per kilogram square. So that is the unit, and this also you have to study. That is 6.7 into 10 raised to minus 11 Newton meter square per kilogram square is G. Now we can calculate. Okay, how we can calculate? F is equal to, we can substitute the values of all these constants. So here G is 6.7 into 10 raised to minus 11 into M. M is the mass of earth, that is 6 into 10 raised to 24 kilogram into small letter m is 1 whole divided by r square. R is the radius of earth, that is given as 6.4 into 10 raised to 6. So 6.4 into 10 raised to 6 the whole square, that is r square. So when we calculate it, we will get the value of force or the gravitational force of attraction between the two is 9.8 Newton. So the answer is 9.8 Newton. So just to remember that here we have to take the radius as the distance between the two bodies, because the earth is having the radius 6.4 into 10 raised to 6 meter, and just on the surface of that we are keeping that 1 kilogram object. That is why we are taking the radius of earth as the distance between the two bodies. Okay, so one is earth and the other one is that object. Clear? So like that we have to calculate the force of, that is the gravitational force between the two bodies. Clear? Now we can move to the fourth question. The question is, the earth and the moon are attracted to each other by gravitational force. Does the earth attract the moon with a force that is greater or smaller or the same as the force with which the moon attracts the earth? Why? The question is, moon and earth are attracted to each other, that we know. And the question is that, does the force of attraction with the earth is greater or smaller or the same as that of the moon which is attracting the earth? Okay, so that we have to find, and the reason also we have to write. So what is the reason for that? So how we can answer that? Here, according to universal law of gravitation, we know that both the bodies, that is here the moon and earth, both will be attracted towards each other. Okay, that means moon will attract the earth and earth will attract moon. So that force, the magnitude of that force we have to find. That is about the question. Okay, here how will be the magnitude of the forces? So here we know that both will be attracted, but according to Newton's third law, we have studied that the force of attraction between the two bodies will be equal in magnitude. That force will be the equal but in opposite directions. Okay, so what we can conclude from this, because according to Newton's third law of motion, the force between earth and moon will be the same, but it will be in opposite direction. So magnitude will be the same, but the direction will be opposite. So like that we can say. So when earth and moon are attracted towards each other, how we can say? Yes, they will be attracted with the same force but in the opposite directions. Okay, the reason is that according to universal law of gravitation, the both the objects will attract each other, because earth and moon will attract each other, but according to Newton's third law, we can say that they will be attracting with the same force but in opposite direction. That is the reason. Now we can move to the fifth question. The question is, if the moon attracts the earth, why does the earth not move towards the moon? We know that earth and moon attract each other, and even when the moon attracts earth towards is, why the earth is not moving towards moon? Why earth is not moving towards moon is the question. So what is the reason for that? So here we know that Earth and Moon attracts with an equal force. That is, gravitational force will be equal but in opposite direction. That we have already discussed in the last question, right? But what about the acceleration in that cases? Here we know that from Newton's second law, F is equal to m into a. Force is equal to mass into acceleration. Here we can find the equation for acceleration. What will be the equation? A is equal to F by m. That is, m is the mass of the body, and here we can see that the acceleration is inversely proportional to mass of the body. Right, here A is equal to F by m, or we can say that A is proportional to F by m. That means the mass of the body is inversely proportional to acceleration. So now we can consider the case of Moon and Earth. What about the mass of Earth and Moon? Here we know that mass of Earth is too much greater than mass of Moon. Okay, mass of Earth is too much greater means here as the mass increases, acceleration will be decreased. Here the acceleration experienced by the Earth due to gravitational pull of Moon is smaller than the acceleration experienced by Moon due to the gravitational pull of Earth. Clear? Because the acceleration experienced by Earth will be less than that of the acceleration produced by Moon. Okay, that means if the acceleration is less means it will not move that much. Okay, that is why the Earth is not moving towards Moon. Okay, I think that idea is clear to you, because how we can answer that? First of all, we know that the Earth and Moon attract each other with a force which is equal. Okay, but in opposite direction. And how we can calculate the acceleration? From Newton's second law, F is equal to ma, then acceleration will be equal to F by m. Okay, that means acceleration is inversely proportional to mass of the body. And from here we know that mass of the Earth is too much greater than mass of Moon. That is why the acceleration experienced by Earth will be too much less than that of the acceleration experienced by the Moon due to Earth. Okay, so that is the reason of Earth not moving towards Moon. Now we can move to the sixth question. The question is, what happens to the force between two objects if the force between two objects we have to find, because there are three cases given to you. In these three cases, what will happen to the force between the two objects, that we are going to find. So here there are two objects having masses capital M and small m, and they are kept at a distance of small letter r. So we are considering such a system, and here we assume that in the first case the mass of the object is doubled. Then what will happen to the force between them? And in the second case, the distance between the object is doubled and tripled. So in these two cases, what will happen to the force? And in the last case, the masses of both objects are doubled. Then what will happen to the force between them? So these three cases we are going to discuss. Clear? So we can look it into one by one. So in the first case, we can see the mass of one object is doubled. So here we have the equation for finding the force, that is F is equal to G mm by r square. Right. So here only one mass is doubled. So here suppose m, so that is doubled to 2m. Then what will happen to the force here? So here we know that F is proportional to G into m by r square. That means the force is directly proportional to the product of their masses. So in this case, what will happen? If mass is doubled, the force will be doubled. Okay, so here we can see if only one mass is doubled, the force will be doubled. So that is the first case. Now we can move to the second case. The distance between the object is doubled and tripled. Now if it is doubled, what will happen? Here we know the force is inversely proportional to square of the distance. So that is F is proportional to 1 by r square. If r is doubled, r is the distance here. If the distance is doubled, what will happen here? Yes, that will be that means the force becomes 1/4 of its original, because that will be decreased, right? 1 by r square is there, so if it is double means that will become 1/4 of its original value. Okay, so the force becomes 1/4 of the original value. If the distance is tripled, what will happen? If the distance is tripled means again, yes, that force will be decreased, right? Here F is proportional to 1 by r square. So here we have reduced, that means that distance is triple increased, means that the force will be decreased. So how much it will decrease? That is, it will become 1/9 of the original value, 1/9 of the original value, because here we are doing that square. That means the force is inversely proportional to square of the distance. So square is there, means that will be 1/9 of the original value if the distance is tripled. And in the last case, what will happen? The masses of both objects are doubled. Here F is proportional to m into m. That means if both the masses are doubled, means the force becomes 4 times. So that is the case of force between the two objects when the cases are applied here. Okay, so when the mass of one object is doubled, what will happen? The force will be doubled. And if the distance is doubled, what will happen? The force becomes 1/4 of the original value. And if the distance is tripled, the force becomes 1/9 of the original value. And if both the masses are doubled, what will happen? The force becomes 4 times of the original value. Clear? The next question is, what is the importance of universal law of gravitation? It is very important law, and what are the important points that you should remember when we talk about universal law of gravitation? What is the importance of universal law of gravitation? Yes, it states that every object in the universe attracts every other object. Okay, that magnitude is given as F is proportional to m by r square. That is proportional to the product of the masses and inversely proportional to square of the distance. Okay, so here we can see that it states that every object in the universe attracts every other object. Okay, and the second thing is that it binds us to earth. So only because of this gravity or this force of attraction, we can stay here in the earth, right? So it binds us to earth. And the next one is, it causes motion of moon around the earth and also the planets around the sun. Only because of this attractive force, it is possible to move the moon around the sun, earth, and all the other planets to move around the sun. Okay, so that is also very important thing that we have to remember about universal law of gravitation. Then it results in the formation of tides. So we can just remember that first one is that every object attracts every other object. That much we have to write. Okay, every object attracts every other object, because this gravitational force is always an attractive force, and it binds us to earth, and it causes the motion of moon around earth and the planets around the sun, and also it results in the formation of tides. So all 2-3 points you have to remember about this universal law of gravitation, importance of universal law of gravitation. And now, what is acceleration of free fall? That is the 8th question. What is acceleration of free fall? In the case of free fall, what is the peculiarity? So what are the features of free fall? Free fall means when an object is falling only due to gravity. There we have to neglect the air resistance also. In such a case, what will happen? The acceleration will be only due to gravity. So we will call it as acceleration due to gravity. That is represented as small letter g. G is equal to 9.8 meter per second square. This is very important point about free fall. So in the case of free fall, only acceleration due to gravity will be there. So that value will be g is equal to 9.8 meter per second square. And that is all about acceleration of free fall. Free fall means 9.8 meter per second square is the acceleration due to gravity, and here the object will be falling only due to the effect of gravity only. Okay, so that means the earth will attract all objects towards the center of its center. So that is all about the acceleration due to gravity or free fall. Okay, clear? Hope it is clear to you. Now we can conclude the video. If you like the video, please like, share and subscribe. Thanks for watching.